So this is something I'm trying to, I'm going to show you guys how to do. I'm just going to show that if you move this particle system around, the script that I wrote is detecting particle collisions, and then it's painting pixels on the texture. Okay, so we have our new scene, and I'm going to create a 3D object, plane, and there's my plane. And then I'm going to take, this is a texture map that's freshly downloaded off the internet, freshly dragged into Unity, so it has default import settings, which is what you see here on the right. And I guess it might have been, I don't know if it's a 2K image. I wanted a 10K image, or a 1K image, which is 1024, but I'm just gonna save us some time and bring it down to, let's say, 512. Let's try 512. And I'm gonna apply that. So I like to use the effects particle system. There's other ways to make a particle system, but this is the easiest because it's more convenient. It creates a game object that has a particle system on it. And by default, it's white and it's aimed up. Oh, I forgot. Let's take that imported image, just drag it over onto the plane. And so if you zoom up on it, you can see the texture of this. So it's not super low res. You know, you can still see some detail, and that's nice. Which leads me to believe we're going to have trouble seeing those pixels. So what I'm going to do with this particle system, I'm going to set the start color to blue. Let's bring those down. Let's check these settings. We're going to need, well, I'd like to see more particles already, so I'm going to set it to 200. And maybe the size can be a lot smaller. So let's set the size to 0.1, or wait, where is it? How about 0.2? And then let's turn on gravity. Where's that? Gravity modifier I'll set to 1. I like simulation space, but I'll show you why. I mean world space, which it's now set to local. So here's local simulation. Now when you drag the particle system around, you see they just follow it as if they're in their own universe, and I'm dragging the whole universe around. If you set the simulation to world space, it just feels like you're moving the emitter and the particles live in the world. Emission rate is fine. I'll leave the shape alone. It's a cone shape. But maybe what I'll do is, so I'm going to X rotate it by 180. And you know what, while I'm here, I'm going to turn on collision. And I'm going to set it to world. It's the least complicated way to have your particles collide with something. And when the particles collide, I'm going to say they're dampened. But what I'm also going to do is set lifetime loss to 1. And now it's just killing everything as it collides. So we have our plane. I'm going to hit save. I'm going to just save my tutorial scene. So we have our plane. So now I'm going to add component and create a new script called particle paint and create an add. Now we have a brand new blank script. Now this is the fun part. And what I'm going to do is occasionally look at this other, kind of my cheat sheet, right? but I think it's going to be important that we do this step by step, because we're here to learn the process. So, we're definitely going to need our texture. We're going to want to read in the texture that's on this game object, and then we're going to take that texture map and manipulate it, and then apply it back onto the plane. So we have these three things. So I'm just going to type them here. We're going to need a texture 2D, and we're calling that working texture, and we're going to need a renderer. Now this is the funny part. I call it Mio renderer because the way I learned this technique, or sort of derived this technique, was by watching a YouTube video tutorial in Italian. I think it was Italian. And I just loved it, that it was in Italian, so I've been using the same variable ever since. So, and then we're just going to have texture. So, working texture is going to be the texture we modify. Mio renderer is actually, I guess, isn't that the name of the component? Wow, you know what? I'm not even sure. But I'm just going to call it renderer component. Now I need to go look that up. But the really important detail, we need our, so texture is where we're gonna read the actual texture map into, and then, but we're gonna manipulate working texture. I wonder if that's redundant. Well, this is just how I learned it. As I go through and start optimizing all my code, I may learn that some of the stuff is unnecessary. Now this is the part that was confusing me, the renderer, and it's called Mio renderer. Now we're just going to get that component, the renderer component, off of this game object, which is the plane. I'm going to hit save. We're also going to read in the texture map, which we get off the renderer. Dot material, dot main, texture. This is kind of a shortcut. What that's going to do is that's going to bring in a texture variable, but we need a texture 2D, so we're just going to put as texture 2D. And then working texture is a brand new texture 2D, where we're going to give it the dimensions of the texture map that we just read in. So it's texture dot width, comma, texture dot height, and let's put a semicolon there. So now we have two new variables we're going to make. We have a color 32, and I guess we're only using it once, so that's why we're defining it here in the start method. So a color 32, we're just going to call that base color, because I thought it would be fun if we overwrite every pixel in this texture map, and then it's a really great first step. Let's just say, so I'm going to set it as a color, a brand new color 32, and color 32 takes bytes instead of floats, so it's 255, 0, 0, 255. So I'm going to skip that source pixels part, but what we're going to do is we're going to go and create a for loop, and we're going to loop through all the x pixels and all the y pixels. But basically, here's our for loop. We're going to loop through the X. We're going to loop through the X from 0. Oh, okay, and X equals 0. That's how that works. From 0 all the way to the width, or actually width minus 1. So that's what we're saying, is as long as X is less than texture.width, and then X plus plus. Hopefully if you're watching this, you understand these programming techniques or principles. So here we go, int y equals 0, y is less than texture dot height, and y plus plus. Now this is the important part. Wait, why are my colors kind of weird? Oh, because that's a minus. Okay. So now we're going to start messing with pixels. We're going to set work texture dot set pixel to our x coordinate, our y coordinate, and we're going to give it a color, so we're using base color. We'll hit save, and we're going to go to our scene and hit play. And I know nothing's going to happen, and I just want you to see that we're not doing it yet. So what we've done is we've modified working texture, but what we really need to do is upload that to our, I guess, renderer, so that it gets applied to the plane. And that's what this line is down here. Oh, actually, okay. This apply line is what that uploads it to apply. That uploads it to the video card. You're also going to need to set your renderer to this new texture. So you need oh, I gotta back that up. Okay, there we go. So Mio renderer dot material dot main texture is now going to be assigned this new texture map. Okay, so I'm going to hit save. Whoops, they want my money. Hit play. Hey everybody, I'm just interrupting for a second because this wasn't supposed to work, and it'll come up again later, so I just wanted to let you know in case you're trying it and it's not working for you. Okay. Now we see that it modified our material. Now this is also what's important to know about working texture.apply, is that it's computationally expensive, or maybe not computational, but it definitely takes time away from other processes. So the other line of code I have in here, which is more practical, is this one, which we're gonna replace our little loop here. We're gonna comment this out. And instead of that, we're just going to say working texture dot set pixels, and this is a great 32 pixels 32. This is great because it replaces all the pixels at once. But we're going to need a new variable called source pixels, which is going to be an array of pixels, which I forgot to create, so I'm going to create it up here. Color 32. Well, it just occurred to me that I had this set wrong. Well, that works. It works both ways with a color and a color 32. So source pixels is equal to texture dot get. Oh, that's strange that it doesn't see what I'm. It doesn't tab complete. Get pixels 32. So what I'm trying to do here is copy the texture that's already on this plane and put it into the new texture map. So this is all the start function. It just runs once. Basically, it created a new texture. Oh, and I forgot to show you something. This is embarrassing. So when I hit play, nothing's going to happen. Actually, I did something wrong here. Line 17. Oh, I forgot the brackets. It's going to look like it's doing nothing. But what it actually did was it replaced the texture map and copied the old one over. So if you look under the shader on the plane and you check this attribute, oh boy, this is confusing. So the reason I'm so surprised is because we had the color changing. If we go back and we uncomment this for loop here and comment out that thing, so it should turn red when we hit play. Uh-oh. Didn't it turn red before? Oh my god. Oh my god, I'm losing my mind. I could have sworn I showed you this thing turning red. I am definitely losing my mind. Okay, so the reason it didn't work is because we need read-write enabled, and now I'm going to apply that. So I had to go back to the texture map and set read-write enabled. So now when I hit play, it changes. So that's cool, and I'm going to flip it back to just copying the texture map. So it's going to look like nothing's happening, right? Right. Moving on. So the next part of this, yes. Wow, that's a lot of code. But we don't need to write so much code. So we're going to write, there's a method in the monobehavior class, and it's called onParticle collision, which takes a game object as a, what is that, a parameter? And or an argument. So what happens is, I'm going to tab that over. What happens is, as soon as a particle, so when Unity redraws a frame, or when it starts the next frame, if a particle hits your object, this method gets called. Other is going to represent the particle system, and through that we're going to look up all of the collision information, which is going to give us the location of the collision and the UV coordinates. Oh, actually, no, that's wrong. We're going to have to do a raycast to get the UV coordinates. But what's important is we're going to know where in world space this collision happened, so that we can, basically, so that we know where to draw our pixel. And this is how we're going to do that. So what I'm doing is, let's look over here. I'm going to copy this integer num, the particle collision event array, and this other thing, which is kind of a throwaway variable, result, because what it's actually doing is looking up the collision info. You know what? And I'm also going to grab that pixel color for convenience. So what we have here, boy, that was lazy. I could have just typed it, but maybe you're tired of watching me type slowly. What we have is, I wanted the number of collisions that are detected in this frame. And to get that, we're going to run So off of other, which is the particle system game object, we're going to get the particle system component off of it, and within that we're going to get safe collision event size, so that we know what size of a collision events array we need, which is what we did here. We created an array of particle collision event variables, types, structs, and then we're just gonna create an array that has that number of slots, so it's a perfectly sized array for what we need. And then this line here, basically we just have we're collecting this number result, which in theory might be the same as the collision event size, but for some reason the docs recommend using get safe collision event size. It might be more accurate. I do not know. Anyway, we're going to go back to that particle system, and then we're going to get the collision events. Okay, game object is this object, which is the plane, and other is also a game object, that's the particle system. And we're basically getting collision events, all the things that have collided with the plane. Those are the events we're looking up here. And we're going to store them in our brand new collision events array. And then we have a pixel color, because I want to color these pixels blue. Oh wait, no, that looks like green. Well, that's odd. This is not, I don't think I was using this when I had it running earlier. So that's very strange. So I'm just going to delete that line. Now this is going to be, there's a whole lot of stuff going on here, but I'm going to make it easy. We're going to start with these 4 lines. Now what we have here, let's move that back. Okay, so what we're doing is we're going to fire array based on the intersection point. Well, starting from the intersection point where the collision happened. And we're going to aim it straight down, which is what this is, negative vector 3 dot up. Yeah, and what's happening is we're going to take whatever information it finds from the thing that it hits, we're going to store it in this thing, in hit. And we don't need a debug log, so we'll get rid of that. And I have this thing, pause. Now, that has not been defined. So somewhere in here, I forgot to define it. Well, what do you know? All these things up here I forgot about. So I'm going to copy those over. Okay. We need our raycast, which is hit, and then we need our position, which is a vector 3, which we're just defaulting to 0, which is 0, 0, 0. We're going to need our UV and our pixel point, which is, both of these are 2D vectors. So what we're doing is we're firing array, and if it hits anything, this will return true, and it'll go into this block here. So we're gonna get our position. We're gonna pull UV textures, coordinates off of the raycast. That's why we shot array, is because we wanted to know the texture coordinate. And that's going to be a 2D vector. And now to calculate our position of the pixel within this image, we need the UV coordinates, and then we're going to multiply the UV by the width and the height of the image. So that's what we did here. Pixel UV.x times texture.width, and then pixel UV.y times texture.height. So now we have all the information we need to draw a pixel at this position on our texture map. And to do that, we are going to working texture dot set pixel. Alright. And it takes 2 integers. Oh, we don't need that. Okay. But we're going to give it a color. So basically, we're going to need pixel point dot x comma pixel point dot y comma and the color. So we're going to use color dot blue. I'm going to hit save, and guess what? We're not going to see anything because I forgot something. We also typed something wrong. On line 40, we need a semicolon. Yeah. So actually, I forgot to loop it. So for int I equals 0, I is less than num I plus plus. And now let's get some brackets in here. That's annoying. So now for every single collision, we should fire that ray, get the UV coordinate, determine the pixel position, and then draw a thing. I'm going to save this file, run this, and I made another typo because set pixel takes an int, and a color. Int, color. I'm going to be lazy. I'm using base color. I'm going to hit save. I'm going to play it. Haha. It's not in this context. So I'm just going to move it up because I'm lazy. There we go. Now, what I do, it's an invalid argument. Int unity engine dot color. Is it because that's a color 32? Well, I'm just gonna wow, we're getting real lazy here. Unbelievable. Set pixel point dot x, pixel point dot y. Are these not ints? They are not ints. So I have to cast them. Wow, losing my voice there. Going froggy. Let's put that back. I think that'll work, but I probably need to cast it. And what I'm trying to show you is that it's not going to work because we didn't apply. We need to set our apply down here. Working texture dot apply. Save it. Run it. Now I think it's working, but this is the problem with having such a low resolution texture. Nope, nothing. So, where did I go wrong? Yes. And this is, I planned this and now I look like an idiot, but it's still kind of cool. So under your particle system, under a collision, you know what? We need to send collision messages. So we're going to do that, and then we're going to hit play. As soon as the wheel of death stops turning. Now, because I was lazy, I set it to base color, and now it's red. But our loop is looping. And our texture is changing color. Let's zoom up on that. Check it out. Let's grab that thing. Move it around. Oh, takes a while to fill in. So there's a couple things just to like make it look cooler. What we could do is go back to our texture map and reduce the resolution of it now. Go to our texture map, and instead of 512, let's make it 128. Hit apply. Hit play. Now that's pretty awesome. Let's move that thing around. Yep. Yep. So that's, we could end there. That's just fun. We could end here, except I kinda want to show you. Huh. I don't know if I want to show you anything else. Okay, yeah. Because let's be practical, right? We gotta be practical. Oh shit, this was a tough tutorial. This took me all night. No, it didn't. It's only 8:46. So all this other shit I have in this thing. Oh wow, I even had this thing going on in an update. Why did I do that? That's a mistake. Huh. That's a major mistake. That's too funny. Okay. So this old script over here. Oh wow. That was a mistake. Anyway. Fits on the screen. This whole... Oh no, it doesn't. Oh well. Let's get rid of the update. Get rid of this. No. Yeah, well, at least the entire... the whole class fits in one screen. Let's get rid of this commented out bit. We don't need that. So that is our entire script. Let's even get rid of this. No, let's leave it. All right, let's stop being lazy. Let's change this. Let's change this to color.blue, which is what I meant to do before. Okay. So there it is. And I hope I can edit this thing into something coherent. I'll probably have to re-record all the audio. Okay, I'm going to leave this on the screen. You can freeze frame it. You can copy it. Hopefully it all makes sense. And I'm going to sign off. Thanks, guys.